Oh man, I don't feel too good.
Oh, so that means that the extra cyanide I put in your drink is actually working.
Cyanide?
Anyways, welcome, gentle listeners, and thank you all for tuning into our video.
So, am I gonna die, or...?
Today, we're going to talk about the general basics of 3D printers and why every component matters.
Kellen? Am I gonna die or not?
I plead the fifth.
That's not an answer!
The first portion of our video will be dedicated to the different types of 3D printers there are.
The 7 main 3D printer types are vat polymerization, material extrusion, powder bed fusion, material jetting, binder jetting, direct energy deposition, and sheet lamination.
According to all3dp.com, vat polymerization produces parts by selectively curing liquid photopolymer resins with a UV light source. Material extrusion, on the other hand, produces parts by printing layers of molten thermoplastic filament, one on top of the other.
Powder bed fusion printers produce parts by selectively melting or sintering powder particles together to form a whole object. For binder jetting, it produces parts by selectively depositing a binding agent over a powder bed. The powder material can be anything from metal, sand, or plastic.
Direct energy deposition produces parts by layering beads of molten material, which is usually metal. Sheet lamination produces parts by stacking and laminating sheets of material cut to match apart single horizontal cross sections. It uses materials such as metals, papers, and polymers.
Lastly, there is material jetting, where tiny droplets of material are deposited and then solidified on the build plate. Using photopolymers or wax droplets that cure objects when exposed to light are built up one layer at a time.
Next up, we have common printer issues. For starters, we have stringing, which is a result of molten filament oozing from the nozzle, which is typically started due to a high temperature issue in the said nozzle.
Actually, I think the most common printer issue is not having a 3D printer at all.
Yeah, that's fair.
Anyways, there's also nozzle clogs, which are caused when filament can't pass through the nozzle, which can be caused by bad filament, wrong nozzle size, or just the wrong filament is being used.
Warping is incredibly common. It's when the edges or corners of a print lift off the print during printing. It's caused when hot filament that's bigger than the cooled filament due to heat expansion tries to cool down and then shrinks, which causes bends and curls to the final print.
And lastly, layer separation is something that occurs when the layers of a print do not stick to each other, which causes gaps in the print. Usually it's because of the bad filament or it's just not compatible with the print.
Now, you're probably wondering how to fix these issues if we ever encounter them. Well, we can often fix stringing by using a lower temperature for your 3D printer, as filament oozing from the nozzle of the 3D printer is the result of a temperature that is too high for your 3D printer and your filament.
For nozzle clogs, they can be fixed by simply replacing or cleaning the nozzle and making sure that the temperature of your 3D printer is in checked. Make sure to check your 3D printer manual.
Warping can be fixed by making sure that your printer bed is at the correct temperature so that the filament is able to stick to the printer correctly.
Layer separation can be fixed by lowering the print speed and by watching the temperature of the 3D printer to ensure that the print is able to stick to the printer bed.
Now let's move on to the different components of a 3D printer. Some of the components of a 3D printer are extruders, print beds, hot end, filament, layer height, slicer, infill, skirts, and brims. Now that we've established what the components are of the 3D printers, now let's go into depth about what those said components actually do. Anyways, these are only some of the components of a 3D printer. There are way more, but if we listed them all, we'd be here for a little while.
Yeah, we probably would.
Now let's talk about the history of 3D printing. The first 3D printer was brought up by Dr. Kodama in 1981 as a prototyping machine, but then Chuck Hull made a patent for it in 1986, who developed the stereolithography process. Also in 1986, Carl Deckard invented the selective laser sintering process. In 1989, Scott Crump invented fused deposition modeling. Even after all these years, these three technologies are still the most used 3D printing technologies to this day.
Another thing to add is that only in the late 1990s and early 2000s did 3D printing actually start to become more accessible to consumers and small businesses. It was only then did we actually start to discover what incredible things 3D printing could do. Like in 2013, when researchers at Princeton University developed a way to print bionic ears that can be heard beyond human capability.
Yeah, today 3D printing is used in a wide range of industries, including aerospace, automotive, healthcare, and even fashion. It has pretty much revolutionized the way we think about manufacturing and has opened up new possibilities for innovation and creativity.
Yeah, technology is coming a long way for sure. Anyways, I'm calling it a wrap from here. Kellen, you can finish the rest of the video from here.
Perfect! Now I can finally take over!
Wait, what? What are you going on about?
I've waited so long for this, Kevin! Ever since you put me in that straitjacket, I've been plotting my revenge. You left me for dead! Now it's finally my turn!
Okay, come on, I only put you in that room for a couple of days.
A couple of days? I couldn't eat or drink at all! You'll find out very soon once you experience it yourself. Get in the straitjacket!
Whoa, hey, hold on!
So, gentle listeners, I hope you've enjoyed the video. I hope we get to see you again very, very soon. Have a wonderful day, everyone. Farewell. Until we meet again.
Let me out! Kellen, let me out!